Hello and welcome to my talk for this year's Qt World Summit. I'm going to give a talk about cross-collaborative Qt GUI testing, a behavior-driven development approach. My name is Florian Turck. I'm a technical sales engineer with froglogic. To give you a bit of information about my background, I gathered experience of almost 15 years in software QA. So I started as a software engineer, became a test engineer, and finally moved on to froglogic to become a software QA trainer and consultant. The company froglogic is a Germany, Hamburg-based software QA tool vendor. We have three different projects, three products which we offer to our clients. The first one was created to become the Qt GUI test automation tool, so Squish GUI Tester. The second product is Squish Coco, a code coverage analysis tool. And finally, not too long ago, we released Squish Test Center, a tool for the central test results storage and analysis. And it also acts as the central integration point for integrating third-party QA tools and requirements engineering tools with Squish. Let's get back to the topic itself. So that's what you're looking for. Cross-collaborative teams. Let's take a look at these three persons here. So I assume that these are working within one company, a company that has a product in the area of computer-aided design. So that's what they are working on. And each of the person comes from a different team. All are involved in the same product, ranging from management over development and finally also QA teams. And of course, these persons have to exchange information. They have to work on specifications for the actual implementation or testing of the software. So let's take a closer look at the profiles of the individual person. First of all, I'd like to introduce Tom. Tom is the product manager of the tool. He does have high domain-specific knowledge. He might have a background in the computer-aided design area, which he formerly worked in, but he does not really know that much about the actual implementation of such an application. He's not a developer. Instead, he's interested in the high-level feature specification because he knows what the users need, and he is responsible for having that implemented and passing on the right information to the development. So here's Anna, a software developer working on the same project. And she, of course, does not have the same domain-specific knowledge as the product manager. But she does know a lot about coding, and she knows how to use the Qt framework to create a fancy GUI. She does know how to implement algorithms, how to optimize them to have them render graphics. But to be able to do this in the right way, she needs a feature specification. And that's her profile. The third person I'd like to introduce is called Steven. So Steven is a QA engineer. He's responsible for the feature verification, and he also validates that the application really does what it is supposed to do. Typically, this is done through testing, and of course, tests can be executed manually, but in the case we are looking at, they will also be automated. Finally, the results of the test executions will be reported back to the product management, and to be able to work on the testing efforts Steven needs a proper test specification. So that's the team, or a representative from each of the teams. How should they work together? How should they exchange information to really create the product they have to create? We at froglogic believe that behavior-driven development is a good approach to do this. So behavior-driven development is about introducing a common specification which can be used by all stakeholders from the different teams. It describes the desired behavior of an application instead of describing the implementation. So it is about what to do and not about how this should be implemented. The specification is written down with the help of an accessible domain-specific language. And in the case of Squish, we decided to use Gherkin, which is a language we have not invented. So you might find that in other tools as well. But typically, it's not used in GUI test automation tools. Anyway, here's a example of such a feature described using the language Gherkin. So just think of an application which is used to register attendees for a conference. In this case, there's 3 steps described. The first one, given there's a registered attendee with the email address foo@bar.com, is a precondition. The second step, when a user tries to register with the same email address, is something you have to do to reach the final result you would like to verify, which is the last then step. So then the registration attempt should get rejected. This is something which could be used as the input for the planning and design, and it could be forwarded to the development team, and finally the QA department could use it to execute tests based on this. And that's exactly what we support in the Squish GUI Tester. Let me give you some general information about the tool first. It is a cross-platform tool for functional GUI testing, so it works on the GUI layer. It supports Qt, both widgets and QML applications running on embedded, mobile, and desktop. It got built-in support for behavior-driven testing, so it's a slight modification of the term, but the concept behind it is basically the same. And it is used by thousands of customers across all industries. Let's move on to the live demonstration to show you what this is about and to really see how all of that works within the tool Squish. This is the Squish IDE, the main tool for the test development, debugging, and test maintenance. I prepared a test suite and I will implement a couple of test cases, but first of all, let's get back to the example. The product we're developing in this example is a computer-aided design software, and as the input to the development, the product management creates feature specifications through a BDD file. So I create a first BDD file, which will finally be a test case. I call that preview because it's about the preview functionality of the application. You can see that Squish adds a skeleton to this BDD file, but I don't want to use the skeleton. Instead, I will start with a prepared scenario here. So this describes how a Q preview should be rendered in the CAD software we are talking about. So it includes steps for the preparation, given I start the application. It includes further steps to be prepared to reach the final verification. So I have to create a new project. I have to enter a command to plot a cube. I click on the preview button, and finally the plotting should be finished. After that, the final verification is specified in a then step, so the cube should be plotted and visible. This is the output from the product management, and it is forwarded to the development team to start with the implementation of the application. I want to show this step as I simply prepared that, of course. So I configured an example application for this test suite, which is a CAD application. After that has been done, the application is delivered to the QA department to finally test it. And the test engineer actually starts automation of the test through the given scenario. So this is quite easy because we do have a recording feature in Squish. So I just click on this recording button to start a test recording, and you can see that the Squish IDE was hidden. Instead, we can see the control bar shows up. It offers me a number of buttons I can use during a recording, but even more important, it gives me an output what I should record now. So first of all, I should start with a recording of the step I start the application. That actually already happened since the application under test was started automatically because of the configuration. So I'm already finished with this step. I move on to the second step, which is about creating a new project. Rather easy, I click on the new button and switch back to the control bar to move on to the next step. I enter the command to plot a cube. You can see that the empty project has been started in the application under test, and on the left-hand side I can enter commands, which then will be plotted in the drawing area on the right-hand side. So that's what I will do. I enter the command cube 10 and move on to the next step. I should click on the preview button, which makes the preview become visible. And now I am prompted to add a check that the plotting is actually finished. So that's something I will record through a verification point. In Squish, we do have verification points to check various things in the application. We got checks for properties of specific GUI objects. You can do screenshot verifications, table verifications, complex visual verification points, and you can search for images and recognize text. For now, I will just create a property verification point. And as you can see, this brings me back to the Squish IDE. It creates an empty verification point creator, and you will notice additional views down here. First of all, the application objects view. This view shows all runtime GUI objects of the application's user interface. I could search for the object I'm interested in now through manually expanding the items and taking a closer look at the children, but I want to use the picker tool because it's much more convenient. So this is available through the toolbar and the little pipette icon. I click on that. I select the console view down here because once the rendering happened, the text changes, and that's something I can use to check that the rendering really took place. Once back in the IDE, I see that the object is shown and another additional view being shown as the properties view, and it includes the runtime object properties of this specific object. And you could check for anything in there, but what I would like to do right now is to check for the plain text, because that changed after the rendering took place. In my case, I don't want to check for the text that is actually displayed. Instead, I want to remove the whole text and mark the expected failure button here. So what that does is actually it checks that the text is not empty anymore, which is exactly indicating that the rendering took place. Let's add that to the recording, move on to the final result. The verification I have to do now is I have to verify that the plotting took actually place and that the graphics have been rendered. So this can be done through a screenshot verification point. I select that from the control bar. As before, I will use the pipette to pick the object, and I enable the checkbox in front of it, which creates a screenshot from the rendering pane, and I click on Save and Insert to finally include that in the recording. I stop the recording, and as you can see, the warnings you might have noticed before disappeared. So the warnings were about missing implementation for these steps, and now I created the implementation through a recording. I will show you the actual implementation in a second, but let's simply execute this scenario. The same input I've done during the recording is done, and once the execution is finished, you can see that the lines being executed are all green now. So that, of course, indicates success, and you can even have more detailed information down here in the test results view. For verifications, of course, this would also include more information in case of failed verifications. So there would be options to actually take a look at the application state through a screenshot being taken during the test run, and also possible values to be checked through property verifications would show up in the result. But we haven't seen the actual implementation yet. So I switched to the implementation file, which is coupled with this feature file actually. So for each recording of a step I did earlier, Squish recorded a Python function, including what is called a function decorator on top. So each step has its own function, and the keyword which is mapped with this is specified up here. Within the functions, you will see a lot of calls to the Squish API to do various things, including mouse clicks, click on buttons, the verifications of properties, also screenshot verifications, and you will also find calls to functions called wait for object or wait for object item. These are actually used to find the objects within the application and to return a reference to the runtime object, which can then be forwarded to a different function for the actual automation. Of course, we need to specify the object somehow. And in Squish, we do have a concept called the object map. And the object map includes information about the different properties and their values the objects should have. So this object, for example, you can see that in the toolbar here, is identified by using the type property and a specific object name, which is set internally inside of the Qt application. You can learn many other things about the object recognition, but time's running, so I will move on to the BDD feature. What happens when you're executing this test is that Squish recognizes the keywords, the freeform text actually used in the feature file. It tries to find a step implementation for this in the step implementation file. And if it's there, it executes the commands of this specific function. Let's create a second scenario, which is a bit more complex because I'd like to include parameters for the edge length of the cube. So I'll start with a second scenario. The name should be rendering a cube preview with a specific edge length. It's quite easy to extend the feature file because the steps I already created earlier are there and can be reused. And as you can see, there's a code completion feature in the Squish IDE, and that makes it pretty straightforward to create new tests based on existing steps. So I do the same as in the first scenario when I start the application and I create a new project and I enter the command to plot a cube. This step I will modify to be flexible with the edge length. In this case, I'll start with an edge length of 15. The next step does exist already, so I click on the preview button and the plotting should be finished. Finally, a cube should be plotted, but again I need to modify this step because I want the edge lengths to be included. A cube with the edge length 15 should be plotted. You can see two warnings about the missing implementation, and it's quite easy to add those two step implementations by selecting the recording missing steps in scenario feature here. So let's do that. Again, the application is started and the existing steps are just executed. I don't need to do that again. Instead, Squish stops at the steps which are still missing. And in this case, it's the step which I added to include a parameter. So I'll do the same as before. I enter the command. Stop recording of this step. Move on to the final step, which I will create a screenshot verification for once again. As before, I select the rendering pane here and I enable the checkbox in front of it. I finally click on Save and Insert Verification and stop the recording. The warnings disappear and I'm able to execute this, but it's not really flexible at this point because I still have hard-coded values in here. So what if I want to enter 20 instead of 15? Let's take a closer look at the step implementation of this step. So first of all, I will just optimize this a bit. For implementation reasons, each keystroke was recorded, but that can be combined in one call to the function called type. Up here we got the hard-coded value and I want to remove that. I used the keyword integer to do that, and in the declaration of the function I will add a variable name called edge length, and this I will use down here. I need to convert that because it's an integer and we need a string here, but this way we can pass on any value to this function. The same has to be done in the verification steps. So the final verification down here. First of all, I will modify the name of the verification point file. So I rename that to have the name cube15. Of course, I don't want the hard-coded value in here as well. Instead, I use the keyword integer again, and I add the parameter edge length once again. once again, I add a string at the end of the cube underscore prefix, and now this function is also more flexible and offers passing on various values. So we can execute this now to see if it still works. Hopefully it does. So you can see that the input is made, the cube is rendered, and the final verification also succeeds. The next thing I will show to you as the final thing of my demo today is prepared in a second test suite. So I'll switch over to that. It looks almost the same, but I created another scenario earlier, which is called scenario outline. It's only a minor modification of the scenario before, but it is included to show you how easy it is to add data-driven tests to BDD as well. So you can see that I replaced the hard-coded values inside of the steps here with another placeholder. I called that edge length once again. It's a placeholder right within the feature file here. And that placeholder name shows up down here again. So here we do have an examples table being specified. And this can be used to specify a number of input values. You could easily extend that with more values to be tested, and also it can include more columns. But in this case, I just have this one edge length I would like to vary. And this way, it's quite easy to really blow up the numbers of tests, to cover all the corner tests which you would like to include in your testing efforts. So let's run this scenario once to show you that. As before, the preparation is done. In this case, the integer used as the edge length comes from the table specified in the feature file. And as you can see, the scenario outline has been executed twice, once for each of the values. All right, that was it, at least for the demo part I prepared for this talk. I hope it was interesting to see the BDD feature live in action. If you want to learn more about behavior-driven development in general, don't miss the website bdd.tips, which is more about BDD in general. If you're interested in our Squish for Qt GUI testing tool, don't miss our website, froglogic.com/squish. Finally, if there are any questions or if you would like to receive a free trial of the Squish GUI Tester or any of the other products we offer, don't hesitate to get in touch with us through squish@froglogic.com or visit our website to request the free trial through the form on there. And last but not least, we would love to hear back from you through our social media channels. It might also worth following us for development tips, feature previews, and product news. Thanks a lot for attending my talk, and I wish everyone a great Qt World Summit. Stay safe, stay healthy, and I hope to see you back next year. Bye-bye.